Welcome you students. Our topic is center of gravity. Center of gravity is defined as an imaginary point at which the entire weight of the body is assumed to act. Okay. The center of gravity is defined as an imaginary point at which the entire weight of the body is assumed to act. Okay, so this is known as center of gravity, right? So in order to understand in a better way, I just want to show the diagram of cylinder. Actually, center of gravity, in the sense, it will be called for the body called a 3D. Okay, and the centroid is just for a 2D plane. Okay, it's for a plane figure, and the center of gravity, it is for the 3D object, three-dimension object. So here I have shown you the cylinder, right? So if I want to just point out the center of gravity, or else if I want to just to bear the entire weight, what I can do is, if I take the center of the body called CG, center of gravity, if I point out through this CG point, then entire weight of the body can be concentrated, or just we can balance it. Okay, it will be stable position. So this point is known as what? The center of gravity, defined as an imaginary point at which the entire weight of the body is assumed to zero. Okay, let us know about the formula of center of gravity for some basic kind of objects like cone, cylinder, sphere, and hemisphere. These are the basic or the objects. So if you know this kind of object formulas, especially S bar, Y bar, and volume, then it is very easier to identify the compound structure or compound solids, right? Fine. Let's begin with the cone. Cone x distance is, just see here, for the cone, the bottom base, which is nothing but measured in terms of diameter, right? And here the height of the object I have noted as h. So this is the center of gravity. I have mentioned the center of gravity as G. Okay, let it be. It's a center of gravity. Fine. So here we need to find from the O distance to this G, what is the X distance. So this distance we need to find. So this is the X or X bar, and this is the Y bar distance. For this cone, X bar is nothing but the diameter of the cone divided by 2 of the diameter. So D divided by 2. Okay, it is D divided by 2. And then Y bar, O to this G particular distance, O to this particular distance can be calculated by h divided by 4. 1 by 4 times of its height. From the O to this G, height or length will be 1 by 4 times of its height. Keep it in your mind. And volume of cone is a familiar one. In the lower class itself we have learned 1 by 3 pi r square into h, pi r square into h, 1 by 3, right? Fine. And move to the cylinder. Here comes cylinder. The bottom base I have taken it as D in terms of diameter, and height of the cylinder I have taken it as h. Okay, so here in the x bar, so we know x bar in the sense, if I take, this is the distance called x bar from the O to this particular G in the x direction, which is x bar, and this is the y bar. This is a y bar. So we need to find the center of gravity for this particular cylinder. So here comes x bar is nothing but, this is the distance, right? So the diameter divided by 2, half the diameter in the x direction, okay, d divided by 2. And when you come to the y direction, in order to plot the y bar distance, which is pretty easy, h divided by 2, okay, entire length divided by entire height divided by 2, or length divided by 2, okay, h divided by 2. Here bottom base d divided by 2 for the cylinder, and the height of the object, it is h divided by 2, okay. And the cylinder volume concern, it is pretty easy for this cylinder. Bottom base area is a circle, so it will be pi r square, and it is a volume, so multiply by its length or height, so pi r square into h, right? So for the volume, we need to specify the SI unit in meter cube or centimeter cube or mm cube. This x bar and y bar is a meter or mm or else a centimeter, right? Keep it in your mind. And the sphere x bar and y bar, it is here, right? So this is the x bar and this is the y bar. So this one we need to find. So x bar is concerned d divided by 2, its diameter divided by 2. Here as well, for in the y direction from O to this particular height g, which is also d divided by 2. Here the diameter I have taken it as d, enter the x bar and y bar is d divided by 2, okay, fine. So volume of sphere concern 4 by 3 pi r cube. Keep it in your mind, 4 by 3 pi r cube, okay. And then move to the hemisphere, half of the sphere, which is called as a hemisphere. So here concern in the x direction we have diameter, full length of it, so it is diameter. And when you come to the y direction, we have only the radius of the hemisphere, okay, let it be. So this is this distance, we call it as x bar, and this distance we call it as y bar. Both of this we need to specify it. Now to identify the x bar, here see in the x direction entire diameter is there, so just like a sphere, d divided by 2. When you come to the y bar here only the r, so here we going to find this O2, this particular height g, am I right? So this is the y bar, not this, okay. So this is the y bar. So this distance we going to find O2, this particular g, what is the exact vertical distance. So here the formula is obtained as 3r by 8. So keep it in your mind, 3r by 8 for the y bar alone. And then come to the volume concern, it is hemisphere, already I said it is half of the sphere, okay. So if you divide it by 2 for this sphere volume, then you will get the answer. So here you will get 2 divided by 3 pi r cube. Just put divided by 2, then this will become 2 divided by 3 into pi r cube, half of this sphere, okay. So I hope you understood how to just take the x bar and y bar and volume for cone, cylinder, sphere and hemisphere. These are the basic object. So by this we can also calculate the compound solids or complicated solids. Okay, fine. And then one thing I have to say, here comes, we are not exactly going to deal with the simple shapes directly. We'll always deal with the complicated or compound solids. Okay, so when you are having the compound solid, already in the centroid itself we have practiced. That means we'll be taking the object into the coordinate xy, and afterwards we'll be just dividing it into simple components, right? So at that time, after finding the self centroid or self CG, center of gravity, we need to just specify the x bar and y bar for the entire components from the O in the with respect to OX and with respect to OY. Okay, so here comes little bit difference in formula. Let me tell you. So compound solid, first one is center of gravity CG of compound solid object. So there actually in the centroid it's a plane figure, so area is a concern. Here it's a object, so here weight is a concern. So when you are taking the first moment, it will be W into x perpendicular distance. Okay, so here if you have a number of object, for example W1 x1 plus W2 x2 plus, it goes on just like this, and divided by W1 plus W2. What's the difference is, instead of area we just place the W1. Okay, it also sum of first moment of weight divided by the total weight. Its definitions comes, right? Okay, so this W is nothing but weight of the object. Weight of the object. Okay, so second case, center of gravity of compound solid is made of same material that is density value is same. If the entire solid, I said compound in the sense it will be made with different kind of simple object. It may be cone, cylinder, sphere, which are all together combined. Okay, each object, if it is made with the same material, if it is a steel, it's the entire object should be steel. If it is some other material, it's the entire object should be a some other material. So that is, the density will be a same. So in such condition, here we have to take volume as a consideration. Instead of weight, we need to take the volume as a consideration. So here it will be V1 x1 plus V2 x2, it goes on, right? And bottom V1 plus V2, and for the y bar it will be V1 y1 plus V2 y2, and so on. It will be V1 plus V2. Here as well y bar will be there in terms of W x1 plus W2 x2 goes on divided by W1 plus W2. The formula will be depends on the number of component. So V is nothing but volume. V stands for volume. So it also first moment of the volume, okay, divided by the total volume, right? here the moment is considered with respect to a volume, there it is considered with respect to weight. In the centroid it is considered with area. Okay, let it be. So now again one more thing, center of gravity of compound solid is made of same material. There it is considered, here it is different material, it is different material. Okay, so for this the density of the each material will be different, density value is different. Okay, so here in the place of volume we consider the density, which is in terms of rho. Okay, rho 1 x1 plus rho 2 x2, and it goes on, depends upon the number of material, rho 1 plus rho 2. And if it is y bar, similarly rho 1 x2 plus rho 2 y2, here it is y bar, so y rho 1 y1 plus rho 2 y2, okay, divided by rho 1 plus rho 2, and it is goes on. Okay, here rho is nothing but density of the material. Okay, density of the material. So in this video we have covered all the basic things included in the center of gravity. So we have learned what do you mean by center of gravity and basic formulas of the center of gravity formulas, h bar, y bar, and volume for some of the basic components like cone, cylinder, sphere, and hemisphere. And we ended with the x bar and y bar formula when the solid is compound. Okay, thank you so much.